Hi, my name is Shannon Seaver, and we're in the middle of a unit called Other Functions. Today, specifically, we're looking at logarithmic functions. We're going to define them, and we're going to look at the properties of logarithms. So a logarithm is seen here in this graph. The blue one here is the logarithm that we're looking at. The red one is an exponential function. So what we're looking at is y equals log base b of x. And the inverse of that is b to the y equals x. So if you notice here that this is the exponential function, this is the logarithm function, and notice that they're inverses of each other. So you need to be familiar with the graph and how it looks of the exponential function and the logarithm function. So we have here 10 to the fourth equals 10,000. I can convert that by setting it up as noticing that this is the base, so that's going to be the base of my logarithm, and whatever this is equal to is going to be what I'm taking the log of, and the exponent is going to become what my log is equal to. So let's look at this one right here and convert it back into exponents. Notice that this is what it's equal to, so I know, and this is my base, I'm going to have 6 to the second equals 36. So converting it back into exponential form, that's how you do that. Here I have exponential form and I want to convert it to logarithms. My base is 2, so it's going to be log base 2. And my exponent is 7, so it's going to be equal to 7, and my last number is going to be what I'm taking the log of. So log base 2 of 128 equals 7. A natural log looks like this. It's an ln a equals b. The base of a natural log is e. E is a special number, and it's the number 2.718, and it's used in banking. It's a banker's coefficient. You see it a lot of times talking about compounding continuously, and we're going to be talking about that in our finance unit more. But the natural log of a equals b can be converted into exponential formula by going base e to the b power equals a. Here's some logarithm properties. We're going to be talking about expanding and contracting logarithms, and this is one of the ways we're going to do it is by using these properties. You need to know that the log base b of m times n is the same thing as log m plus log n. Log base b of m over n is the same thing as log base b of m minus log base b of n. So notice that this is plus, this one's minus. We have m to the a. This little power goes to the outside of the logarithm, as you can see here. So log base b m to the a becomes a log m. And one of the things I wanted to point out to you is that log m equals log n only if these two happen to equal each other in the first place. Log base b of b, so if they are if the base is the same and what you're taking the log of it is, it's going to be 1. If you happen to have log of 1 of anything, is always going to be 0. And then the last thing I wanted to point out to you guys is a to the log a. Notice that these are the same base. If you have this format, the answer is going to be b. One last thing I want to show you before I switch the screen, and hopefully you guys have written all this down because these are important and you should probably have a reference card for this. We typically, everything in our number system is base 10. So anytime we have just log base 10 of x, lots of times this 10 is ignored and just left out. So log 10 is like, these two are exactly the same thing. Log 10 of x is the same as log x. So sometimes they just drop that base 10 and it's assumed. And you should know that your calculators are in base 10. If you have a TI Inspire, you can change that base, but if you're in a normal scientific calculator, that will be in base 10. So that's something else you should write down. So let's use those properties that we just learned about to expand this. We're in log base 4. We're going to keep it in log base 4. But notice that we have 5 times x to the third times y. So the first thing we can do is go ahead and say log 4 of 5 and just add these because they're being multiplied. X to the third and then log 4 of y. Now notice this is to a power, and because it's to a power, I can move that to the front using our properties. So now I'm done expanding this particular logarithm. On part B, there's several things that are going on actually that we're going to have to take pieces of it. First of all, this is one piece and this is the other, and it's being divided. So I'm going to go ahead and divide it up like this. Minus natural log of 7. Now this is as simplified as far as we can go, but I need to look at this particular equation right here and simplify that further. I can rewrite that as 3x minus 5 to the 1/2 power. So because I can write it like that, I can move that half out in front. I'm just going to rewrite this. Okay, so it's 1/2 natural log of 3x minus 5 minus ln of 7. Okay, so one of the things that you might be tempted to do is to take this a little bit further and break this down and distributing that ln, the natural log. You cannot do that in this case. You can only further expand it if it's just pure multiplication. So if it was just ln of 3x, then I could have expanded it further. But because it's 3x minus 5, there's an addition or a minus operation going on inside of here. This is as far as I can go. Now let's go backwards. Let's condense these back into one logarithm. So first of all, I know that I have this 1/2 out front, and I can move that to an exponent, and same with this 3. So let's do that first. So I'll have log x to the 1/2 plus log x plus 1 to the third power. And now, because there's this addition going on, I can make that one logarithm with these two being multiplied to each other. So now it'll be log x to the 1/2 times x plus 1 to the third. Now let's look at this one. This is out front. I can move it to a power right here. So this will be natural log of x plus 2 to the second minus natural log of x. Because this is a minus, I'm actually dividing. So my final product will be x plus 2 squared over x. And this one's a little bit trickier. We're going to work from the outside of this. And notice that there's a 1/3 on the outside of these brackets. So I'm going to actually distribute that 1/3 to both of these. So it'll be log base 2 and 1/3 on the outside plus 1/3 log base 2 of x plus 1. Now I know that I can make that a power to both of these. So let's do that. Log base 2 of x to the 1/3 plus log base 2 of x plus 1 to the 1/3. And because these are being added, I can end up multiplying them. So it'll be log base 2 of x to the 1/3, this should be a 3, times x plus 1, and this should be also 1/3, to the 1/3. So that is my final answer on that one. Okay, so that kind of concludes our quick overview of logs and expanding and contracting or condensing them. If you have any questions, please bring them to class tomorrow.